This is the 8:1 multiplexer 74151. So from this notch, the first left pin is the pin number 1. So it is a 16 pin IC 1 to 8, 9 to 16. It's a 16 pin IC. What are all these 16 pins? Out of these 16 pins, 8 pins are the input pins. So I0, I1, I2, I3, I4, I5, I6, I7. These are the 8 input pins. These 3 select pins, S0, S1, S2. S0 is the least bit, S2 is the most significant bit. Like we are doing it in terms of variable ABC, then this will be A, B and C. And even here, this is the most significant bit I7, I0 is the least significant bit. So out of the 16 pins, these 8 inputs, these 3 select bits. So 8 plus 3, it is 11. Then 1 VCC in order to make this IC work, VCC and ground. So 12, 13 pins has been done. So 2 output pins. So I think it's miss out here, it's a Z bar. So Z is the output, Z bar is the complementary output. Suppose if my output is 0, I'll be getting the complementary as 1. If output is 1, complementary will be 0. So 13 pins has been done and 14, 15 pins has been used. And one more pin is here that has been written as E. This is an enable bit, or sometimes it's called as a strobe. So when we provide the input for this, based on that, this IC will be enabled or disabled. This is an active low enabled. When we provide the lower input for the pin number 7, only then the IC will be activated. Lower input in the sense we need to provide the voltage 0 to the pin number 7. Voltage 0 means we need to connect this to ground. That is how we can make this IC work. So VCC ground is mandate in order to make this IC work. Along with that, this enable bit also very much required, even this pin number 7 to be given to ground in order to make this IC enabled. So based on the inputs whatever I apply, based on the select inputs whatever I apply, that particular input will be connected as an output. So suppose if my select bit are 0, 0, 1, means I want to be my output. Whatever this input I'm receiving at pin number 3, that I'm going to get across pin number 5. That is how the multiplexer will work. Now we'll look into the design part of the multiplexer, how we can reduce 16 inputs into an 8 inputs. We need to simplify this expression f of ABCD is equal to summation m of 0, 1, 4, 5, 8, 11. So we'll use the implementation table in order to simplify this. So the expression given is f of ABCD is equal to summation m of 0, 1, 4, 5, 8, 11. Now either I can reduce for the variable A or I can reduce for the variable T. When I want to reduce for the variable A is the most significant bit. If I want to reduce for A, I need to follow this because here is the least. So this direction I need to write the entries. Wait a minute. So if the most significant bit has been reducing, so then we need to follow this direction of writing the contents 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. When we are reducing it for D, we need to follow this direction because this is the least bit. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now what we need to do, what are all the minterms given? Put a circle for those minterms. So it's been given 0, 1, 4, 5, 8 and 11. These are the minterms given. Put a circle for that. So in case of this, yes, 0, 1, 4, 5, 8 and 11. Just put a circle for that. So now when we look into this, if both has been circled, then we need to write this as 1. If only first row, then it is complement of the variable. Both have not circled, then it is 0. Now only below, so it is A. It is above A bar. It is above A bar. Both have not circled, then 0, 0. So now in order to work for D, both have been circled, so 1, Yeah, just shift this. Yeah, both have been circled 1, not circled 0. Both have circled 1. So I think it's not working for me here. So just this is 1. So then here it is 0. Here it is D bar. Here it is D. Here it is 0, 0. That's what we are going to get it. So once we get these inputs, now we need to draw the circuit for this. So either we can draw the circuit for A or we can draw the circuit for T input. So but how you need to draw the circuit, we need to remember. Now we need to draw the circuit. So it's a 8:1 multiplexer. I've written the pin diagram, the features of the 74151 IC. So the 74151, we have an VCC, it's been connected to this. So this pin numbers we need to write it. Now I'm not writing the pin numbers, but you can write down the pin numbers. This is pin number 16, pin number 8 and pin number 7. So 16 should be connected to VCC, 8 should be connected to ground. This enable bit or the strobe should be connected to ground. So pin number 5 is our output. So we'll be extracting the output across this. So these pin numbers, you can just look into the pin diagrams and write down what is I0, I1, I2, all these pin numbers. And these are the select bits, that S2, S1, S0, that pin numbers you can write it down. So then we need to draw the circuit here. So in order to draw the circuit, what are the inputs? So now I'll be reducing in terms of A or in terms of T. Since I've already written here ABC, so I'm reducing in terms of D now. So this I0 and I2 is 1 should go to VCC, and wherever it is 0, all those things should be connected and given to ground. D bar should be extracted from the input, D bar from the inverter input, and D directly. So your D is of pin number 5. I'll just connect that D, that is pin number 5 should go to D, then not pin number 5, input 5, okay. This I4 is D bar. I4, we need to use an inverter and the output of the inverter to be connected to I4. Then next, this I5 connected to D, this I4 connected to the inverter output. So that is D bar. Now I'll just connect these VCC. I0 and I2 should go to VCC. Or else I can just connect it here, or I can write it as VCC here only. Anything is fine. Now these things, I1, I3, I6 and I7. I1, I3, I6, I7 connected to ground. You can just connect it to this ground itself by drawing. Otherwise I'll just write it here. I1, I3, I6 and I7 should go to ground. So this is how we can do the circuit connection of 74151 IC. You can write down the pin numbers for all this by looking into the pin diagram. So pin numbers of these inputs, you can refer to this pin diagram and you can able to write it. I0, it's pin number 4. So this is 4. I1, it is 3. I2, it is 2. I3, it is 1. Then I4, it is 15. I5, it is 14. I6, it is 13. I7, it is 12. So this pin diagrams will be provided even in the test and in the exam. You can just refer to this pin diagrams and write down the pin numbers. You need not to by heart the pin numbers. Only thing you need to know how to realize the circuit. So how to design it, and once you find out the inputs, how can you draw the circuit and what inputs to be provided for all this. That's what you need to learn it. Yeah, with this I'll wind up this session. So similar to this, any expression can be given. You should be able to draw the circuit, design and draw the circuit for that. I'll just extend this question. Suppose if I have a don't care. So some two terms, I'll just write it for pin number 15. 10 and 15 are don't care, suppose. How can I draw the circuit for this? So 10 and 15 should put a circle. So these are the don't cares. Now I can't write this as 0. I can't put a circle. I can't put a circle for this. What I can do is these two, whether it's useful in order to simplify the expression, then I'll be using this as a 1 in order to make the maximum number of ones in a group. But since these are don't cares, now I'll not be circling this. I'll just make these combinations open. So this I7 will be open and this I2 will be open if I'm realizing that in terms of A. If I'm realizing that in terms of D, so this I7 will be open, then 10 will come here. So don't care and 11. I want to make use of this don't care as 1. Then this will be 1. But if I'm writing this don't care as 0, then this input will be D. So it all depends on what is your don't care. Suppose here I'll make it as 1 because I can make this and I'll simplify this expression. So here I'll consider this don't care as 1. So by grouping these, I'll be getting this result as 1. But by considering this don't care like don't care, since it's not useful for me, I can just make this open, that is don't care. So this pin number I7 pin. So this I'll just make it open. So by considering this 10 and 15 as don't cares with respect to the variable D, so this 10 I'll be considering it as 1, so I'll be getting this result as 1. So this don't care I'll not be considering, so this is don't care. So now these changes I've done in this. So this I7 left open, this I5 has been connected to VCC since it's been considered as 1. Suppose if you don't consider this or considered as 0, then this will be given as D only. That is how we need to do the circuit connections. So similar to this, any given problem. So the expressions will be given by the examiner. They can be having a don't cares, with don't cares or without don't cares or whatever the inputs. So you should be able to design and then able to draw the circuit. This circuit you need to realize it on the real hardware components. Yeah, with this I'll wind up this session. Thank you.